Welcome again, Wildcats. All right, so today we're looking at Wednesday, March 29th, and we'll be solving exponential and logarithmic equations. That's going to be on page 68. Now, a little video note, there's not going to be a video for Thursday because on Thursday is when you'll be taking the English 2 EOC. Okay? So, pause the video and update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, so we're solving exponential and logarithmic equations, and that's going to be on page 68. Now, solving exponential equations has three methods, okay? Method 1, graphing. Method 2, same base. And method 3, take the log of both sides. If you would, go ahead and pause the video and update your solving exponential equation methods. All right. Next, solving logarithm equation methods. Okay, there's two of them, okay? Method 1, make an exponential. Method 2, use log properties. All right, so pause a minute to update your solving logarithm equation methods. All right, let's take a look at our examples. All right, so it says, for example, 1, 2, and 3, solve the equation using the same base. All right, well, we're not going to do example 1 on the video because you can see the same base. So I think you can, if I explain example 2, you can do example 1 without any problem. And you're probably going to want to ask questions about example 3 in class. Okay, so example 2, well, we see the right side has a base of 2, so we want to make the left side a base of 2. So we know it's 2. We think, well, 2 to what power gives us 8? So we know, well, 2 to the third power. So that's 2 to the third power, don't forget the x, equals 2 to the x plus 6. Okay? Now the bases are the same, so we know the exponential equals, so we have 3x equals x plus 6. Okay? We subtract x from both sides, so we get 2x equals 6. And then we divide both sides by 2, x equals 3. All right, so pause a minute to finish up example 2. And also, you know what, go ahead and try example 1 as well. And then again, we can go over example 3 in class. All right, example 4. Okay, so solve the equation by taking the log. Okay, and then don't forget to check. Okay, so we see that the base exponential is 3, so we're going to take the log of base 3 to both sides. Now remember, if it's an equation, you can do whatever you want as long as you do it to both sides. So since I took the log base 3 of the left side, I'm going to take the log base 3 of the right side. Okay, so we know that the log base 3 of 3, since the bases are the same, that becomes 1, so you get 2x equals log base 3 of 25. Divide both sides by 2, so x equals log base 3 of 25 divided by 2. All right, let me pause a minute to get a calculator. All right, so let me put this in to see what we got. Make clear whatever this other person's work is. All right, so control 10 to the x power. So that's log base 3 of 25 divided by 2. And we get 1.46497, which will round to the third decimal place, so 1.465. All right, and so let's check. So that's 3 to the 2 times 1.465 equals 25. So let's put that in the calculator. So 3 raised to the 2 times 1.465. And you get 25.0015, which we're okay with because remember we rounded. Okay, so this checks. And so we can say that x equals 1.4, I should say approximately 465. Those squiggly equal signs means approximately, since we rounded. All right, so pause a minute to finish up example 4. And I think you can try example 5 on your own, and then we can go over in class just so you can check your work, just like example 1. I'm hoping you tried it and we can check it in class. All right, let's look at example 6 and 7. I'm just going to go over in class. I think it'll just be better if you had the ability to ask questions about it as we work through it, okay? All right, example 8, 9, and 10. To solve the equation by making an exponential, okay? So going back to when we took the log of both sides, the bases are the same, these become 1. We're going to use that same concept in that since the base of the log is 4, if we raise both sides by base of 4, so we're basically saying 4 to this, 4 to that, then this will become 1. So then you get x squared equals 4 to the 7th power, okay? All right, so then you get x squared equals 4 to the 7th power, which is 16,384. Take the square root of both sides. Remember, the square root is plus or minus. So x equals a positive 128 and a negative 128. All right, but it says check, so let's go ahead and check. So we have log base 4 of 128 squared equals to 7. So when we put that in, let me clear this out. We do control log base 4 of 128 squared equals 7. So that checks. And then we do log base 4 of negative 128 squared equals 7. Which I'm going to control click copy, press enter to copy it. And you see that it's a non-real calculation. Okay, so that tells me that this does not check, so our solution is x equals 128. And we need to talk about what we say about this in class. So look up solutions to the logs and then see if they explain what the solution is and when it's not a solution. Okay, because we need to talk about that in class. All right, so that should get you kind of started on the examples and kind of ready for class on Wednesday. So with that, I think you should have a terrific Wildcat day and go get some Wildcat sandwich crackers. All right.